Okay, so we have this problem here. I've underlined all the important information. 5 kilograms of water is going to be your mass for object 1. The initial temperature is T initial for your water. Object 1 is heated by 2 kilograms of the hot material dropped into it. So this is your mass, object 2. The final temperature of the water is 35 degrees Celsius, so that's your T final of water. And the change in the temperature of the metal, so I gave you the change in temperature, is 80 degrees Celsius. What is the C of the metal? Okay, so the way you're going to set this up is, remember from the lab, the negative Q of one object has to be equal to the positive Q of the other. In other words, if I lose heat, I have to gain it somewhere else. Okay? In this case, the hotter object is going to lose its heat energy, right? So that's going to be the metal, right? So I'm going to go ahead and expand this. Negative M C change in T, negative M cat, right? Has to be equal to the positive M cat of the water. Okay? Let's go ahead and figure out which one of these am I solving for. This is my metal, right? My metal loses heat, the negative metal heat, like a rock band or something, must be equal to the water getting in heat. Okay, so this is my metal side over here. Okay, so I'm looking for the C, right? So how do I get rid of M and change in T? Well, if they're multiplying, I'm going to divide by negative M and by change in T. Okay, whenever I do to one side, I do to the other. Negative M, change in T. Okay, so my C is going to be equal to the M cat of water divided by the negative mass times the change in temperature of my metal. Okay, so let's plug these in. So my mass of water was 5. My C for water is 4180. And my change in temperature was 35 minus 30, 5 degrees. Gained temperature, right? Then divide by the negative mass, which was 2 kilograms of the metal. So my change in temperature I gave you was negative 80, which is good because I'm going to get negative times a negative here, right? All right, so 5 times 40, 180 times 5 again, divided by negative 2 times negative 80. Okay. So we get a C, or specific heat capacity, of about 653. And this makes it really close to the specific heat of calcium. So the metal you were using is calcium. You usually don't think of calcium as a metal, but it is a metal, because it is on the left side of the periodic table. If you were, obviously, you wanted to solve for mass, you would do this exact same process, but you would divide by the specific heat and the temperature instead, right? So just be mindful. Like if you have two objects mixing together, just put negative Q equals positive Q, so negative M cat equals positive M cat, and then just solve for whatever variable you're looking for. Looking for the change in temperature, you could do that by dividing by negative MC. If you were looking for the C on this side, again, just divide by M times change in T.